Okay, welcome to this report. I've got this one from my blog on European News Weekly, the Fifth Estate, and I did a report for Nuclear Hot Seat, which is a radio podcast based in the US, and I do a weekly report there. Now, of course, one of the big issues that you're seeing on the internet, it's been covered by a lot of alternative blogs and what have you. We're looking at the issue of the radiation spikes that were reported in January. They happened in January, but they got reported in February. And I just wanted to expand, because I only get 5 minutes on Nuclear Hot Seat to actually explain what was going on. Now, the actual releases in January, that was one big plume of iodine-131, which comes from either criticalities, nuclear explosions, or medical sources. So a reactor that makes medical isotopes for cancer treatment and other things as well. So what we saw was that the iodine-131 release that was reported in January by a French sort of NGO or a French organisation, and they basically turned around and I'll just take us to that right now. Right, so this is the picture that you'll probably be seeing on the internet, and I think I'm going to zoom in on the source. Okay. We're looking at Poland had 5.92 plus or minus, and I think that's actually micro becquerels per. Actually, I don't know what the reading is on this one. It doesn't actually say. But bottom line is, when you're looking at it, it's quite a low amount, okay, which was measured in the air, and we were looking at. As we got further away up into Norway, we were getting much lower, 0.5, 0.27, and in the south 0.3. So as you see, as you go further south, you start to see higher values for this iodine-131. Now if we go out to Spain, we get 1.28, okay, and then when we come into France, we're getting much lower values, sort of a tenth of that value, and then when we're coming further sort of to the west, we're looking at 0.45, to the east we're going 0.45. It's kind of measured in southern Germany, but these are the mountains, these are the Alps all around here, okay, and what you'll see is if the iodine is released into the air, wherever it rains, you'll get a hot spot, okay. So as we move further, we're getting 5.92. The highest value was measured in Poland. Now, there's no measurement in the Hungary, Czech, Ukraine, Belarus, and these all have working monitoring systems. And we have something called EURDEP. I'm just going to take you there. So, EURDEP. We'll go there. Right, let's pop that up. You have to click accept on this one. Shall I center this up? Yeah, I think I will. So we'll go on to EURDEP radiation monitoring, and if I just pull the screen back a little bit, you'll notice that Ukraine still is switched off, okay. So what we're looking at really is certain ones in Sweden are switched off at the moment. Portugal is switched off. That's down there. Portugal is switched off. Now there's been various releases recently, okay, and when I take you there, I'll just show you this. Now up here they've got 1 day. So what I'm going to do now, the other thing I should point out very quickly is that this is Belarus here, and you see that high spot there, that purple spot. If I was to click on it, you'll see it's a much higher value, right? Well, actually, I won't click on it yet. It's not such an interesting thing, but it's more than it's 400 nanosieverts, so it'd be 0.4 microsieverts. It's a very high value, but that is by the Chernobyl contaminated area. So and then just south of that you'll find sort of around there somewhere is the Chernobyl power plant in Ukraine. All right. Now, obviously you'll also notice that the Russian monitors are all switched off. They're all switched off as well, and that's today. Okay, so now what I'm doing, I'm going to go over here. I'm going to click on 1 month. All right. I'm also going to go below here. I'm going to click on maximum value. Okay. I'm going to leave it on T gamma because I happen to know they're not allowing any other isotopes to be tracked. You can get them when it's good, but when it's bad they turn the other isotope option off. I'm going to pull this back a little bit and you can see, you'll be able to see where all the monitors are all across Europe. Okay, and now you can see the map as it should be working, where all the actual monitors are connected up to the EURODEP system. It's quite extensive. It goes straight into Russia. We've got Finland, Sweden. Finland has got a good amount of monitors. They're very efficient, and Russia. And you'll notice there's lots of spikes and what have you. So they're all over the place. Now this one here, for instance, would be a reactor. We'll go to it. We'll click on it, and we'll just show you the level of spike. Oh, hang on, I hit the wrong one there. I'll have to zoom in a bit more. They've got, there'll be 2 of these actually. Oh, there's 3. All right, let's pick one. All right, hopefully this one should come up okay. And this is because, all right, we've got up to 6,400 nanosieverts, and to convert that into microsieverts, we're going to go 1, 2, and then basically we've got what's it? I think it's 6.4 microsieverts peak. And if I click polyline, oh, hang on a minute. There you go. Sorry. Pick polyline. You can see that there's this. All right. So 800 is 0.8 microsieverts. Okay, and well, we're nearly up at, say it's nearly about 6 microsieverts. It's a peak. It's a very short peak. I think it lasts for about an hour, and it's because this reactor is off-gassing its gases. It's doing a refuel, and it's likely to have bits of cesium, iodine, and all sorts in it. If we were to pull this one back, they obviously had another one within a week, so we go to 2 days. Oh no, I'll have to do a week. There's some missing data. You'll see there's some missing data here on February the 20th to the 21st. So basically what we're saying here, and I would say on February the 22nd, which is this morning, they've switched off again. Now this is quite normal when there's a radiation release or expected radiation release from a nuclear power station, because they don't really want those spikes popping up all over the place. They tend to take them off, and they, under orders of the International Atomic Energy Agency, who run the German server for this particular one. There's another one in Italy as well, but the German one can switch off these monitors, so people like me can't find them. If we were to go here, well, I mean, basically, let's have a look at this one. So we've got another purple spot, if you like, and this is Hungary. So this is the area which I'd be concerned about. You'll see there's a gap there again. All right, now that's showing that there is, and I'm going to hit polyline, so because that normally show any, yeah, we've just got a line there, if you see, on February the 5th. That's after January, so on February the 5th. And that's basically because they wanted to hide the big spike that you saw in Germany there. And there's another little break there, and there's another little break there, and another break there. So over the last couple of weeks there's been some issues. I'm going to go back a month. Now going back a month, once again, we're not seeing any, there's data missing there. We've got a little blip there. there's data missing there, and that's the January period where basically we're looking at a release, a big release over some hours, which could have been that little gap there, and there is a little tiny gap there as well. And I suppose if we zoomed in, we'd see, I think it looks like another little gap there. But the bottom line is around about the 4th or 5th of January, there was some issues. But what we're saying here is that Hungary are very good at hiding these large peaks. Now, this peak could have been, it could have been 20, 100 microsieverts. It could have been anything at all. And most importantly, it's what isotope was it? Was it radon that you get from doing refuels with some iodine, some cesium, or was it mostly iodine with different iodines? Now, going back to the map, I want to tell you something. The IAEA, their server here, they have access to much more details, and if I bring you over here, you'd get an idea of the type of nuclides they're able to access. And if you look at this list here, it's a very extensive list. It goes uranium, thorium, gamma, T, beta. These are all types of energy. And of course we've got the specific isotopes, Pb214, Pb210. Let's have a look and see if these are working. Sometimes they don't hide these so much. So I've just clicked it, it's refreshing, and okay, so we're getting the Germany is actually showing some peaks, and let's go to that. Now, if it was the Hungary one, we'd expect to see peaks of iodine. Okay. Now this is in becquerels per meter cubed. Okay, so we're getting up to a normal amount might be a very low amount would be sort of 1 or 2 or 3 becquerels. It'd be down the bottom here somewhere, and if you can see the mouse, hopefully. It would be the lower points here, and as you can see here in January the 29th, it was right up at the top here, 35 becquerels per meter squared. Now if I go back before January 29th, no data can be found at this time. Okay, why is that, you may ask? Well, with the Hungary reactor I found in the past, though, and I'm going to link the findings I had, was that in the UK there was lead found in the water, and it was above the limit. It wasn't a huge amount, but it was above the limit, and it was supposed to be notified, and people were supposed to be notified that there was X amount of lead in the water, at least to stop their kids drinking it and things like this. But they didn't. And in 2011, when this Hungary incident happened, they basically turned around and we saw huge issues with the high levels of lead that were released as well. There was a coincidence, if you like. So I'm just showing you the German PB was high at the end of January, and before that the data was switched off. It's not available. You can draw your own conclusions on that. So anyway, this is going to be a fairly long video. But anyway, so what we're looking at here is the data being switched off. Now let's see if the data was switched off on others. Right, so okay, we've got this here. Now of course Germany itself does produce its own lead in the air, and then there's from Poland they get lead from sort of various processes. Now so let's go back. Alright, so we're now in January. Okay, so we're getting sort of peaks, regular peaks. Let's go back again. And I would say that's getting lower. That was down into November. And then before that. So we're seeing there's quite low values, 12. But when we come up to date, and go back one, we're getting 24, we're getting double the value towards the end of January. We're getting little peaks now as well, and we know that the things are switched off, the monitors are switched off. Okay, so the next little bit I want to bring you to, I've gone to Slovenia. We're measuring, I don't know if you can see it, but it's iodine 132, and we've got a 0 measurement. Okay, and I've just put the chart up here, which is zeros. I'll just bring that across, 0 0 0 0, and then I'm going to get rid of that. Now it's only showing one that shows iodine 132 in Slovenia here. I'm going to go to iodine 131. We'll see if any come up here. Normally we get some up in Finland, we get 2 in Slovenia. Let's see what happens. Okay, so we've got a few here. Right, now if we go to this particular one, right, we've got the Czech Republic, and we've got a 0 measurement. Okay, once again, we go back a month, and we've got a 0 measurement, but in January the 15th, right, or will be January the 16th. It's very hard to tell because of the way they've done it. Let's do it 1 week at a time. Alright, we'll go back. We'll go back. Okay, so they're not measuring any iodine from February the 6th. Okay, but let's go back a bit further. February the 6th. So January the 30th to January the 24th. The oh, hang on a minute. January the 30th. There might be a gap there, but anyway, let's go back further. January the 16th. They've all got 0 measurements. So Czech Republic, according to this, didn't measure anything. I'm not so sure that that is the case. This is another area. We've got an orange one here, or yellow I should say. Okay, and here actually is very interesting. We can see it's switched off. You can see the gaps in the measurements. Right, taking a measurement midweek every week or something by the look of this. All right, let's do polyline. And you can see they do 1 measurement a day. Now they do actually have this live, right? And when we go to January, we can see it's all been switched off. There's 1 little measurement there, but in the other sort of weeks, nothing. And even in December as well. Okay, so that's another issue there. All right. So how are we going to find the source? Because they're switching off on EURDEP to hide. IAEA are switching off the monitors, taking off the peaks, not reporting fully on EURDEP, which is the public mapping system paid for by Europeans, to find out what's going on, used by the emergency services to find out where plumes come from and what have you, so that they can manage emergency situations better. And I've shown on other videos how they've manipulated the system. Now, fortunately for us in France, there is actually this crowd, and there's also CRIRAD and what have you. So if I take you here, this is a report I did for Nuclear Hot Seat. I'm back here again. Now, what I said here basically was that the Budapest medical isotope in Hungary in 2011 and 2012 had a big release. Now I said the 2011 one I was able to tie to lead in water, and it was found in birds, and this is all in the UK that I did my research, and the UK government stopped reporting it, after 2010 was their last official report of levels of lead in water. And they stopped reporting it, and now they just say on their annual reports, yes, no, the lead levels were okay. They don't give you the lead levels like they used to prior to 2010 and before. They changed the format of the reporting, and mainly because of this Budapest Medical Isotope Institute in Hungary. So. Fortunately for us, a crowd called CRIRAD, right, a French NGO, it was set up after Chernobyl to measure radioactivity, managed to work out using the URDEP sort of map where this radiation was coming from, and they found it in Budapest, and they measured iodine 125 and iodine 131, and especially several kilometers from the nuclear site itself there was heavy contamination. Okay, now they warned the locals not to drink milk and leafy vegetables. Now the iodine 125 is fairly problematic, because whereas the iodine 131 is quite short-lived, iodine 125 in this situation was much longer-lived. Now we never got reports tying in the lead, right, with this situation. Okay, but they did report more than one type of iodine. Now the iodine 125 you can't find. There's no option for it on the URDEP mapping system that we were looking at. Now they did a report, and what they were saying was that this particular crowd and the nuclear lobby, the nuclear industry generally in Hungary, were hiding the releases. So when these all nuclear establishments have to report to the IAEA and say, well, look, we had X amount of meters per cubed of release of this isotope or that isotope, pollution basically, and that is noted down and reported on, and all the studies that the nuclear industry use are based off that. As I showed you there, where all the switch offs are, they're hiding peaks which would add to those becquerels per meter cubed to the annual amount that's released. And so basically we're seeing that Hungary were really bad, because they were having a lot of extra releases that went unreported. The IAEA tried to cover that particular 2011 one up. They were saying it was Fukushima, it was Pakistan, it was here, it was there, but in reality we did track it to Hungary. And the URDEP mapping system was used to work much better to do this. We actually tracked the levels of radiation back to Hungary quite obviously. Now CRIRAD have done it in this case, but they've managed to get it to 2 countries. So I think they were saying it's either Czechoslovakia or Hungary. But Hungary has this particular laboratory not laboratory, but this particular medical isotope institute is known for making big releases and huge plumes that cover the whole of Europe, especially with iodines. So anyway, we went through it. I was just, in my report I showed little plumes, but I also reported on the German one. I reported that in Spain there was a bit of an issue there. The neighbouring countries will do switch offs. I also reported that the Flamanville nuclear reactor that was had problems the week or so ago. Having lots of problems and switch offs and refuels going on over Europe. And what's happening is that it's confusing everybody as to what's going on. But it's just, if you're aware of these situations, I did a report which showed that the wind directions from Flamanville would actually head towards Ireland. Now that was when that was actually happening. It went across the Channel Islands, straight up to Ireland, and it would hit Cork. And in fact, about a week or so later, they obviously were doing some sort of release from that plant or a plant nearby, and it reached Cork, and it went from 0.1 microsieverts to 0.2 microsieverts. Now that's not big, but it was reported. But quite interesting enough, last Sunday, which would have been Sunday the 19th, early in the morning I was looking at the URDEP mapping, and I realised that all the Irish monitors were switched off. Now that was just last Sunday. Now that could have been from Sellafield release, it could have been from a French release, it could even be from a Spanish release, because this radiation does travel. Okay, but this was a separate issue, and it could confuse people if they aren't aware of that Spain has some really rancid reactors. and so does France, and so does the UK. They've got, France and the UK have Le Hague and Sellafield, which are nuclear reprocessing. They're often venting out radiation, and they vent it out, if possible, not across the country, because they're on the eastern side of the country, on the coast. They will actually vent out when the wind's going out to sea, and possibly when it's stormy, so that the whole thing will be mixed up. And of course, Ireland and Norway and Iceland, will get hit, and it will come back into Europe as well, because generally you have circulatory weather patterns. They don't go in a straight line to America, they circle around, and they're hoping that by the time it gets to Norway it will be quite low. Now you can see here the Norwegian monitor was switched off. This is the map from Sunday morning I did. So if it was Sellafield, the wind was going north, or if it was from France, the wind was going north, it would hit Ireland, it would hit Norway. There'd be little peaks, but they just hide those little peaks, partially so that you can't trace them where they're coming from, because I was doing that quite a while ago. Now, I mean, I did NRPA also. There was another issue there up in Norway. Why they're so sensitive at switching off their monitors, because they're actually hiding their own nuclear disaster, or accident at least, where the thorium, the hope of the nuclear is the thorium reactor, and they have one working in Norway. It produces steam, and it's used to in a paper factory, right? But the main point of it is it's actually an experimental thorium reactor, which is what the nuclear industry hope to develop. But this one, anyway, the actual fuel rods melted down in situ in October. They waited a while to report it, because they do that so that you can't track the weather reports to see where these releases are coming from. So they have a general policy of delaying the report until for the latest amount, a bit like TEPCO did in Fukushima, basically. So thorium reactors basically are, the fuel melted down, it started producing iodine-131, and they closed the building down, vacated it, and they've sealed it, and they reckon that they're dealing with the iodine. But there's been no more reports, not to say, well, we've got it sorted out now, we've dealt with the fuel, we've done this. This is 2 months later, or 3 months later really, and there's no report on the NRPA .no website. The last one was November the 4th, I think, vaguely. So that's the issue there. So I'm going to sort of leave it here now, and I just wanted to explain to anybody who is interested what's going on in Europe at the moment. All this nonsense about Russia. Russia does its own releases from its nuclear reactors as well, but in this situation we know where the actual radiation is coming from. And if you notice, read some of the articles that are put up by Mainstream, they do mention medical reactor as well as other sources, but they do mention medical reactor. And to be honest with you, there is only one major medical reactor used in Europe, and that is based in Hungary. It's run by the IAEA, in terms of, and it's protected by the IAEA, who have access to the European radiation monitoring data. There is no need whatsoever for an American plane to come over and check out where the radiation's coming from. They're doing that as an exercise because there's so much radionuclides in the European air at the moment, in the last few weeks, and probably planned, that they're going to use that to work out, use the military systems to work out with radiation plumes. It's an exercise, and of course the papers have picked up on it, and now they're saying, oh, it's Russia, it's Russia. No, it isn't. It's Hungary. It's the European Medical Laboratory and medical reactor that where old people get their sort of medical sort of isotopes from. It's under pressure. To create certain isotopes, they have to vent other isotopes. Iodine-131 is one that they're throwing away, and other ones like iodine-135, was it? Let me have a look again. Iodine-135, lead, all these, radon, all these they don't want those. They want the various other isotopes for various other medical procedures. and to create those they create a lot of pollution basically. Now, this is a very old reactor in Hungary, so it is very dirty, and the people around there is a health risk. All right, maybe not for the rest of Europe, but there is a health risk for them. And that's it. Thank you.